Hi, it's Mrs. Moss here. Today we're going to continue our meteorology discussion and talk about wind. Now, I'm sure none of you have ever thought about wind before. You just go outside and feel it. But where does wind come from? How is it created? We're going to talk about that now. Wind is the horizontal movement of air that's caused by differences in air pressure. And now that we learned about air pressure as being air forcing down on you, the weight of it forcing down on you, or lifting off of you, we can understand wind. Winds are described by the direction they come from. So when we see here on the news report, there's a northeast wind that's coming from the northeast. Winds redistribute energy. They blow from regions of high pressure to regions of low pressure. So let's think about that again for a second, and let's talk about how that is created on Earth. Well, air pressure changes are due to unequal heating of Earth. We saw this in our last slide, right? So if we know that air pressure is created by different temperatures, and we see that the Earth is a round shape, different areas are going to be heated differently. And because of that, we're going to have differences in temperature, but we're also going to have differences in density of the air and differences in air pressure and humidity. So let's take a look. We have regions that we consider to be the poles, which are the North and South Pole. In this picture, we see the North Pole very clearly. We also have the equator, which goes around the whole entire Earth, and it is exactly at where the circle part comes out. So it's going to receive energy differently. Let's fill this chart in. We have lower temperatures at the poles because it's of the way it's facing the energy from the sun. And at the equator, we have higher temperatures. This causes higher pressure at the poles and lower pressure at the equator. This also creates higher density and lower density. One at the higher density at the poles, lower density at the equator. And at the poles, the humidity is lower, and at the equator, the humidity is higher. So when we look at a weather map, we can actually predict where the wind will be based on these white lines. They're called isobars. If you remember from our last video, barometers measure air pressure. So when we see the word BAR, we're going to associate that with air pressure. Barometric pressure is another way of saying air pressure. So barometer, barometric pressure, isobars all refer to air pressure. Now on this map, these are called isobars, and they show different regions of air pressure. And the interesting part is, if you look closely, you can see areas where there are lines closer together. You can see areas where the lines are spread out, and that's going to indicate where the wind blows. Now, in general, I told you before, winds blow from high pressure to low pressure. So that would indicate that this high pressure is going to be blowing outwards like that towards that low pressure. And the winds are going to come in towards that lower region of pressure. We can also use the isobars to determine where winds will be faster. So faster winds occur where the isobars are closer together. Let's look at that map again. The region where the isobars are closer together would be right in this area here. So we would predict that that area would be very windy over Idaho and Wyoming. In this area, we see the isobars labeled with the inches of mercury, 30, 29.8, and 29.6. So if we remember that winds blow from high pressure to low pressure, we would predict that that wind would be blowing in the the southwest direction. And we could also tell that this area here around the high pressure has faster winds because they are closer together. And the area that's coming towards that lower pressure has more spread out isobars, so that has less pressure, less wind. Now, we call this a northeast wind. Although it's blowing southwest, the name of it is going to be northeast wind because they are named from where they come from. We have to remember that. The greater the air pressure difference between two regions, the greater the wind speed. So this is just a little about what we saw before on that map. So if the distance between two isobars are greater, then what happens to the wind speed? The wind speed will be slower. This is what we call an anemometer. An anemometer is the instrument that measures wind speed. It measures it in miles per hour, or it measures it in knots. Now you are responsible for remembering this, even though it's a tongue twister. You do need to know this instrument. A wind vane, which was in the picture that I had on my first screen. Some of you may have these on your houses, or you've seen them around. These wind vanes measure wind direction, so they tell us where the wind is coming and going. Land and sea breezes. When we go to the beach, we feel more wind sometimes, and that's known as a sea breeze. Well, let's talk about how that's created. Why is it so breezy there? Well, we said that winds are created by changes in air pressure. And if we think about specific heat, which we talked about in our last unit of energy, land heats up faster, water does not. So the heating and cooling of the land is going to generate changes in air pressure, and that will create winds. So let's look at this a little more closely. During the daytime, as I said, the land will heat up faster than the water. So warm, low density, low pressure air will form over that land and rise. So from here, the wind goes up, and as it blows over or comes over higher up, it will start to cool. Well, that cooling air will sink, and then it creates a breeze because winds are then going to go from high pressure to low pressure. This area is considered high pressure because the air is pressing down. The region over the land is considered low pressure because the region is air is going up. So we have what's called a sea breeze. Winds blow from high pressure to low pressure, so it creates a breeze from the sea, cooling us off on the land. And this just reiterates what I said. The cooler high pressure air from the sea replaces the warmer lower pressure from the rising air, and it results in a sea breeze. Now everything changes at night because at night the land cools down. So that's going to change the pressure as well. So when we have when we have the land cooling off, the air above it will be cool too, and that will create sinking air or a higher pressure. Now, because the water has a higher specific heat, it holds that heat in. So it's going to be the warmer of the two at night. So over the water, as I said, the lower pressure is there because the air is warmer, allowing the air to rise. And as it comes over the land, it cools off, so it sinks. And this results in what we call a land breeze. The breeze goes from area of high pressure to area of low pressure. So here the breeze or the wind comes from the land. So what is this creating? We've talked about this recently with rising air and then warming up rising air and cooling and sinking air and creating a circular pattern. Do you remember what this is called? A convection current. You're right. So land and sea breezes are like mini convection currents. All substances heat and cool at different rates, like the land heats up faster and the water heats up slower. Why? They all have different specific heats. And we spoke about this before, so I'm not going to get into it now. But if you remember that wind is caused by the changes in air pressure, and air pressure is caused by changes in heating and cooling, then we are at a good place to stop for now. I'll see you next time.